to balance the equation, we have to write the equation out and then start substituting possible values till we have a balanced chemical equation. So let's begin by writing the equation. We have tetraoxosulfate 6 acid reacting with aluminium to give water and aluminium sulfate. Here we have W, we have X, we have Y, and we have Z. So now, next thing, we'll still write the equation again. But this time, we'll be having dash, that is space for the unknown. We won't be putting the variables. So, looking at this equation, it is obvious that it is not balanced. And we need to balance it. So, where do we begin? If we should start with hydrogen on both sides, it will be making it complex because we have 2, we have 3, that's 5, and we have 2 here. So why not, let's begin with aluminium, because since that has a small values on the product side, we have 1 in the reactant side and the product side we have 2. So to balance that, let's just add 2 as a coefficient here. This makes aluminium balanced. Yes. Then the next element, let's consider sulfur. We have 1 in the reactant side, and in the product side, these 3 here will be affecting each of the elements present in the compound. So we have 3, that is 3 multiplied by 1, we have 3. So to balance this as well, since we have 3 in the 3 atoms of sulfur in the product side, let's add 3 also. This makes it 3 in the reactant side. Let's check so as to balance it in the product side. So now let's start with hydrogen now in the reactant side. 3 multiplied by 2, that makes it 6. 2 times 3, that's 6. That makes hydrogen 12 in the reactant side. So in the product side, we have 2 atoms present. So 12 divided by 2, that's 6. So we'll be adding 6 here to make hydrogen balanced. Do not forget that aluminum is balanced, then our sulfur too is balanced. Since we've not added anything here, that is to aluminium sulfate in the product side, nothing is affecting aluminium and sulfur. So let's check for oxygen if it is balanced. So we have 3 multiplied by 4, that's 12. And here in aluminium hydroxide, we have 2 multiplied by 3, that's 6. So 12 plus 6, that makes 18. 18 atoms of oxygen in the reactant side. Let's calculate that of product side. 6 multiplied by 1, we have 6. Out of 18, we are left with 12. Let's see here. 4 multiplied by 3, that's 12. That means oxygen is balanced. So for here, we will just add 1 as a coefficient. So with this, we can say we have a balanced chemical equation now. So let's write the equation. We do not need to put the value of 1 because it is insignificant writing it. We don't write 1 as a coefficient in chemical equation. But anytime we do not see values in front of a compound, then we know obviously that it is 1 present there. Now substitute the values of W, X, Y, and Z. So from here we can see W equals 3, S equals the values now 2, Y equals 6, and Z equals 1. So with this, we've come to the end of the solution to the question, and we've gotten the value of W, X, Y, and Z to be 3, 2, 6, and 1 respectively. That will be all. Do it to subscribe for more if you find this video helpful.